Hi, this is Trey Lath from OpenHelix. Today's tip of the week is on Mapper. Mapper is as it says here, a platform for the computational identification of transcription factor binding sites. It's actually a nice tool, and I'd like to show it to you. There are three basic parts to Mapper. There is the Mapper database, which is pre-computed transcription factor binding sites upstream of genes in human, mouse, and melanogaster genomes. There's the search engine, which is an on-the-fly search, and it will search human, mouse, melanogaster, C. elegans, or yeast. And then there's our Snips mapper, which, as it says here, is designed to identify single nucleotide polymorphisms that may have an effect on the presence of one or more transcription factor binding sites. So let's show here, right here, the result is a list of TFBS whose scores change significantly from the allele substitution caused by the SNP. So we're going to take a quick look at this. Now, you do not need an account at Mapper if you don't want, but if you want to save your searches and return to them, etc., you will create an account. It's completely free, and you can do that right here, as you see, a link there. There's more information here where you can register, the home, the models, etc., some community information, etc. But we're just going to go right to the Mapper database. So let's do that. We're going to do the pre-computed ones. Now there's different ways to search. You can search by genes or genes in a pathway, identifiers, or by models, and then choose your organism and homologs, and then the models. You can choose from libraries or if you have a specific model you want to look at. So let's take a gene. In this case, I'm just going to do one of my favorites, clock, and I'm going to just choose all the libraries here from Jasper, Transfact, and Mapper, and run that. Once I do that, it will give you a name for the run. Now again, you can be notified, put your email right here, and get notified when the data is done, but we're just going to start the run. Now again, if you wanted to save this, you will have to register, but again, that's free. So as you see here, it's preparing to run, and it will take a little bit as it looks for transcription factor binding sites upstream. Once it does that, it will have a summary of the transcription factor binding sites upstream of the clock gene, as you see here. You can filter this if you wished by e-value and score. You can look at your input. You can change the display. Let's go back to the summary. You can click on any one of these, and it will give you the gene ID, ensemble link, etc. It'll give you the model and factor, the alignment, and position, etc. So you'll get some immediate information, and you can link out to different places, for example, in the genome browser here at UCSC, and you find some information. So that's the database, and as you see, it can pull out lots of information for you. So let's go back to the home page and scroll down to the bottom here, and let's go to the our Snips mapper. I'm going to click that. Now what this does is find SNPs that the change in the alleles will cause a change in the transcription factor binding site. So let's take a look at Alzheimer's disease. So we're going to take genes in the pathway. We're going to find SNPs that will change the transcription factor binding sites that have been predicted upstream of these genes in this pathway. So let's click that. As you see here, there's 296 genes. We are going to enter that information. Click Next to select models. So we do that, we'll choose our models. We're just going to choose all three just to get more information. There are 5,100 SNPs here. And click Run. As you see, we can start our run now. And we will have to wait for our data. So now we have our results, and as you see, we have our SNP that affects a transcription factor binding site and some information about that here. As you see, the position, etc., the SNP, the factor, the model, etc. So that is Mapper and some things it can do. Check it out and check us next week for our next tip. Thanks for coming by.